Thank you. All right, everyone, we're going to go ahead and get started for today's session. So thank you, everyone, for hopping on to our recurring Azure123 webinar series for EDU. Today, our second topic of our 6-week series is going to be on saving money while improving resiliency, specifically using Azure Backup and Disaster Recovery. My name is Rich Lilly. I am with Netrix LLC. Netrix is a Microsoft Premier Services integration partner focused on many things, one of them being Microsoft technologies. My name is Rich Lilly, and I'm a cloud and data center evangelist. My role at Netrix is a sales engineer, and my goal is to help educate customers on various technology, including Azure, which we'll be talking about today. A few shameless plugs for myself. I have a blog that I run called thecloudabove.com. You can find me on LinkedIn. As well as you can tweet hopefully nice things at me on Twitter at @RichLilly. Let's go and get started. So today, we've got about an hour or so here. We're going to cover a handful of topics. We're going to lead off by first talking about the difference between backup and DR. We're then going to dive into Azure Backup, backup using Data Protection Manager or Azure Backup Service. Then we're going to cover off on disaster recovery using Azure Site Recovery. And we'll wrap up with migrations using Azure Site Recovery as well. So where I really like to start typically is really talking about the difference of backup and DR. A lot of organizations may not view them as different functions, but they really should be treated as different functions. Backup and DR are two uniquely different processes. If you have backup, you don't have DR necessarily. If you have DR, you don't have backup. We start by talking about the purpose of backup, which is really to allow for the recovery of data that was inadvertently deleted or maliciously deleted or breached or compromised data. An example of this would be if a user deletes a file off of a file share, deletes an email from an inbox. In this scenario, you need to be able to recover either that mailbox, that item, the file, the folder, the server. And it does not necessarily overlap with what is disaster recovery. For example, would you necessarily turn up your old version of your entire Exchange server if a user deletes an email? It's probably a lot more overhead than folks would like to handle in a recovery type of scenario. Same thing would go for a DAG node, or the same thing would go for any infrastructure server. So when we talk about backup, it is really critical and key that you maintain your current backup or new backup processes will not, taking that over with something like disaster recovery. Now, on the flip side of that, disaster recovery actually allows for the recovery of an app or a data center during an outage. And this is specifically from a point in time or up to multiple points of time. Disaster recovery is something that can be fairly costly. We'll talk about in just a few minutes. So we're going to talk about how Azure helps solve some of those problems. Disaster recovery would be used in an example if a flood destroys an office or the power goes out for an extended amount of time and you need to service your faculty and students without impacting your ability to serve your end users. Would you actually ship, though, tapes to a secondary data center and build those apps from scratch? Many of you may be doing something like this today through a service like Iron Mountain, or you may have a colo provider, or you may have someone taking home drives in order to recover that data. But as we all know or may know, in a lot of cases, that process itself can be extremely time-consuming, on the order of days, weeks, to get data back into a consistent, usable state. In that time, there's obviously a significant impact to both your users, being your students and your faculty. So if you take one thing away from today's session, backup and DR are not the same. You should absolutely treat them as separate entities. We're going to first start talking about backup itself. I'm sure everyone has seen all the news articles that have been out there today, but ransomware is one of those things that having a consistent backup of your data is absolutely key to have. It's also a great example of why backup and DR are two separate things. If I have a server that is infected with ransomware, my file server, and that data is actively replicating out to the cloud every 30 seconds, well, if I don't catch that issue within a 30-second time window or less, I'm going to replicate all those changes to my disaster recovery instance. And now I have an instance that's also infected. Prime example of why you want to keep those two pieces separate. the FBI has actually made came out and made some recent recommendations, and that backups are absolutely critical to resolving ransomware incidents, specifically leveraging cloud-based resources that are off-prem, because attackers or malicious attackers can also even potentially breach backups as well in some scenarios. And just a fun fact, ransomware, as I'm sure we all are aware, is up about 3,000%. That's a huge number since it began in 2012. Prior to 2012, we really didn't have a lot of ransomware types of attacks, hence why you see that that number go up so high. So within Azure, there's a couple of different backup scenarios that Microsoft supports. One of those happens to be a cloud-based backup. So when you talk about provisioning new workloads in the cloud, when you talk about having backups, you want to take that data off premises, both of these are examples of how you would use Azure as another backup target. Now, when you provision new resources in Azure, or even when you fail resources over into Azure, you're going to need to back them up in probably a manner that's not consistent with how you do it on-prem today. Through the Azure platform, Microsoft offers a handful of ways in order to back up those resources, such as Azure VM backup, called Azure Infrastructure as a Service, or IaaS backup. There's also the Azure SQL backup, which is a platform-based backup that I can retain SQL backups for up to 10 years of databases in the cloud. Also supports, by the way, integrating with SQL 2014 and 2016 as well. In these cases, it's absolutely critical to have backups of that cloud-based data. Now, more likely, if you have not taken that leap into the cloud just yet, and this series is really focused on helping you do that, you may have a hybrid cloud backup scenario. In this scenario, I need to take my data and I need to move it to another site. Today, maybe that's replicating to a drive or tapes and going off through a different provider. When you have the access to Microsoft, that can replace some of those scenarios from a co-location perspective. Today, Microsoft has a handful of options for hybrid cloud backup. Natively called Data Protection Manager in the System Center suite, which can back up all of your on-prem workloads as well as replicate that out to the cloud and tape if you so choose to. The other option you have is integrating with what's called Azure Backup Server, which is it's a layer weight version of Data Protection Manager that's now a part of the Azure Backup Service. I also want to highlight the fact that if you don't have an all Microsoft solution or don't want to go with an all Microsoft solution, and I'll tell you how Microsoft's made some huge strides in this area in just a few minutes, there are also options to integrate with other third parties. So, for example, if your backup provider today is someone like a Commvault or a NetBackup or a Semantic Backup Exec or a Veeam, they actually support natively backing up to Azure storage. Vendors work in different ways. Some of them back up directly to Azure Blob Storage. And if you guys didn't attend my last session, that's one of the cheapest things out there. Azure storage in general cloud storage is really the race to zero from a cost perspective. Current public pricing on storing data in Azure is about 2.4 cents per gigabyte per month. That means for about $22 a month, I can store a terabyte of data. That means for, about $2,200, I can store about 10 terabytes of data. I'm sorry, $224, I can store about 10 terabytes of data, and about 100 terabytes for about 2,200. Now, in education, you guys also have having some extremely aggressive pricing from Microsoft. So those prices can be cut by as much as half in some scenarios. So if you have a question on any of the pricing that's offered up to you today, please feel free to reach out to your Microsoft representative to discuss that further. One of the great things about having that cloud storage that's extremely cheap is I will almost guarantee you that 10 terabytes of storage on-prem is going to be roughly 2 to 5 times the cost of what Azure storage is. So again, this race to zero really impacts how you store that data and where you store that data. We're going to first start by digging a little bit into Azure IaaS Backup, which is, again, allowing you to really back up infrastructure as a service resources. This can be Windows VMs. If you guys haven't seen the announcements from Microsoft, they have a huge broad support of Linux in Azure as well, so we also support backing up Linux VMs. SQL workloads, as well as anything that may be backed up on Microsoft Premium SSD storage. In this case, you may want to leverage this in scenarios like VMs in Azure that have been deleted or corrupted. If you want to perform an application-consistent VSS backup, backing up without shutting down a virtual machine, which you don't want to have to do because it's going to affect the delivery of your services, and also the ability to retain data for various compliance needs as well. The great thing about this as well is if you want to go try this out today, there is pay-as-you-go subscriptions, which you can go put on a credit card, but just be aware that you are paying public pricing. Again, being in the EDU market, you guys have extremely aggressive pricing, and one of the call to actions here is the fact that you can go work with your Microsoft account exec or your procurement team to talk about how easy it is to add, even $100 of Azure a month to your agreement. And again, that $100 will get you a significant amount of data in the cloud. It's very, very cheap to kind of store this amount of data.
Just to add to that, Rich, it's Simon Ebbett, the Microsoft's account exec. The $100 a month is the minimum monetary commit you can add. So again, very cheap. The second part of that is that if you add it to your campus agreement, your OVS agreement, you get a 36% education discount. You also get access to the apps portal and to the enterprise marketplace.
Perfect. Thank you, Simon. Again, some great advantages there by adding this to your campus agreement for a fairly low cost. There's a couple different scenarios in which Azure Backup, IaaS Backup supports today. So we're running a full VM. So this may be due to a corruption or the VM, something happens to the VM itself. And I can actually restore that as is, or and overwrite that existing service. I can also restore just the disks. So say I do have a malware incident on a file server in Azure. I don't necessarily have to worry about recovering the entire VM because it may take a little bit longer, but I can just recover volume. And in that model, I can recover that and I can bring it up, and the impact and recovery time will actually go down even more. As well, we all in preview today, this was announced just a couple of weeks ago, Microsoft will also allow item-level restore of VMs in Azure. So keep in mind, the great thing about Azure IaaS Backup here is there's no agents for you to deploy. Microsoft actually has this as a SaaS-based solution. So you're not managing a backup server, you're not installing it, you're not patching it, you're not upgrading it like you would with your traditional, Commvault, Veeams, NetBackup, whatever on-prem today. And I still have the same level of capabilities around VSS snapshots, the ability to recover individual files and folders or individual parts of an application. This gives me a lot of flexibility without the overhead of having to manage an entire backup platform. So let's walk through what that actually looks like. So I've got an Azure Recovery Vault here. So this is the Azure portal. For anyone who hasn't seen it before, I'll be primarily working out of this portal. There is also a legacy Azure ASM portal, which is a light blue, older portal. If you are working in Azure today, I absolutely recommend you work in this portal. About 90% of the functionality has been ported over at this point. And that reason is that the old portal is going to be going away, I believe it's February or March. So this is definitely something you want to consider as you're starting to deploy Azure resources. Now in Azure, I've already gone ahead and provisioned what's called a backup vault or recovery services vault. Contains both a configuration for both backup and disaster recovery. So we'll start by walking you through disaster recovery. Now when you think about backups and how they work today, the foundation is really what am I backing up and what's the policy for that backed up data. Now in this instance on the left-hand side, an option for backup policies here. Again, normally I would be logging into a Veeam, I'd be creating a policy, but again, this is a completely as a service model. So I have a default policy that I've configured here, and it has the basic settings you would expect from a backup. And I also want to point out any data that's stored into Azure for backup is also deduped and compressed, much like you would have on premises today with various backup solutions. So, your actual backup sets aren't going to be, full backups every single time, and you're not going to have to, double, triple, quadruple, 100 times your data. My backup policy is pretty straightforward. I have a daily backup at 11 p.m. Central Standard Time. We retain that backup for 30 days, so that 11 p.m. backup gets retained for 30 days. I also have the ability to then retain a weekly backup point, which I do for 1 year. We also add the ability to do a monthly backup, which I have set for 2 years. And yes, that last one is accurate. We can, in fact, do a yearly backup for 99 years. I absolutely hope Azure is around that long, but if you want to retain your data for that long and you have compliancy purposes to do so, Microsoft has those options built into the platform. So once I have a backup policy configured here, Sorry. I then want to apply that to a resource. And again, what we're talking about now is primarily Azure infrastructure. So we'll get over to the on-prem protection in a second, but this is all based on resources that exist in Azure today. So if I go down here to my backup items, we'll see that I have a handful of VMs that are being protected today in the cloud. I've got a couple different test VMs here, and you can see the backup success, which there's also alerting and notifications here, just like you would expect on-prem. We can see that those backups finished, in about between 9 and 12 minutes. Now, if I want to, I can go check out exactly what's happening as a part of this VM. Here's one of my VMs in Azure I just clicked on. You can see I've got 30 restore points in the last 30 days and 7 in the last 7. If I wanted to, I can also initiate a point-in-time backup that's out of band. So if I have a reason doing a service pack upgrade or doing some type of maintenance on the weekend that's not, doesn't meet my 11 p.m. policy. I did talk about the restore option. So if I go to restore here, we do have an option to go ahead and restore that VM in its entirety back into Azure. So again, this would be a scenario where I may need to restore that based on, a VM being in a bad state or being infected with ransomware. I also want to point out that Microsoft does support encryption of backups, which I think was just announced a couple of weeks ago as well. So you can see right now I've got just crash consistent backups. I don't have any workloads on here that require VSS. If I did, we'd also see app consistent or files consistent backups as well. The Azure Backup as a Service, again, fairly plug and play. We've got our policy, we've got our VMs. If I wanted to and I had other virtual machines I want to protect, I can simply go up here to add. And again, I don't have to go ahead and deploy any agents. I'm going to identify how do I want to back up that VM. So I want to back up an Azure virtual machine. We select our backup policy, which is the one that I showed just a little bit earlier here. So we'll choose our default policy when it loads here. And then what we'll do when that comes up is we'll load our virtual machines in Azure, and I think I've got a couple others that we can add to that protection policy. So I'll go ahead and hit OK here. I'll validate the retention range and the policy meets my specific needs. And then last but not least, we're going to go ahead and get prompted with a list of VMs in Azure I can back up. So if I wanted to go back up my web application proxy or my test VM here, I would go ahead and hit OK. And I'm not going to actually go ahead and finish this, but when I hit enable backup, what's going to happen is it's going to deploy it's going to enable the add-in for the agent, which is already on the virtual machine itself. And then we'll begin protecting that VM based on the policy. So at this point, at 11 p.m. tonight, it would initiate the backup of that VM. And then certainly I can go back here and monitor the status of that. As I mentioned, there's also an alerting and events pane here, so I can go back and generally see what's been going on. I can also send out alerts to maybe my IT distribution list. I don't have any set up here today, but again, allows me to kind of proactively make sure my backups are in fact happening as I would expect. All right, so that is Azure Backup, Azure IaaS Backup, excuse me. So in addition to backing up resources that already exist in Azure, and if you haven't made that jump yet, again, think about it as you're deploying IaaS resources or platforms such as SQL. There's also options to back up that data from an on-premises scenario. So as I mentioned, there are other vendors that are out there today, such as Veeam and Symantec and a handful of others that do support integration with Azure. I'm not going to talk through those today, but I can certainly take a follow-up if anyone has any questions on how Veeam or Commvault or any of the other respective vendors do integrate with the cloud. I'm certainly happy to take that offline. For this purpose, though, we're going to be talking more about the hybrid cloud backup leveraging Microsoft's Data Protection Manager or the Azure Backup Service. And I'm not going to be able to demo this today, but just kind of talk about what this actually works. And again, this is integrating with your existing on-prem platform. So for anyone that has Hyper-V and is using DPM, natively as of 2012 SP1, it does support backing up to the cloud. Now, in the simplest manner, this works very similar to how I have my Azure IaaS backup. In this model, the only difference is I have a backup server on-prem I maintain, and I'm going to connect that DPM or that Azure backup server to Azure, which both of those have options of backing up that natively. If you are backing up resources on-prem and you're not moving all to the cloud, which I imagine most are not on this call, there is still a great use case to make sure you retain a cache of backups locally. I always recommend if you have on-prem infrastructure that you maintain at least 7 or 14 days of backup on disk on-prem. The reason being is if you have a catastrophic disaster that you don't have Azure Site Recovery enabled on, you want to be able to recover massive amounts of data in a short amount of time. Or if you have a 1 terabyte file store locally, the last thing I want to have to do is pull down that 1 terabyte of data from Azure, because it's going to be really limited based on your internet connection. I should also point out, though, that the key part here is having that cache on-prem for recovering that large amount of data. But again, as you get then into your secondary tier, and I don't want to store more than 14 days because disk is expensive, tape is expensive, paying Iron Mountain is expensive, that's really where the cloud comes in as another egress point. I should also point out that if you're a smaller shop or you have an environment where you have maybe just a couple of servers in one of your campuses that are not managed by a central backup platform, Windows Server also has backup agents for Server 2008 through 2016. It supports individually backing up VM machines, I shouldn't say VMs, physical or virtual machines directly to Azure. The downside of that is very one-to-one management. There's not a central console, so as anyone who admins backup environments knows, having that central console and that experience is going to be key. But again, there can be certain specific scenarios where you may want to do individual level machine backups. Also, Microsoft made some significant enhancements and announcements at, I believe, just prior to Ignite this year, where they do actually, in fact, support VM or VM-based backups. This is a big shift for Microsoft, as you've seen them do around things like Linux and supporting non-Microsoft solutions. They now support VMware 5.5 and 6.0 VMware-based backups. This is completely agentless. If you own Data Protection Manager today, you can actually do this. It will work on backing up both vCenter will work both on discovery of vCenter as well as backing up individual ESXi hosts. So if you don't have a production environment that's using vCenter, maybe you have a smaller environment, you can also talk directly to ESXi hosts. This supports folder-level backups, and that data can be stored as a source on any NFS, SAN, or DAS volume. It allows you to also recover in-guest data from any Windows virtual machines, and then certainly, big advantage, backing that up to Azure storage as well. So again, don't just think of Microsoft as a Microsoft-only backup platform here. We realize a lot of you guys probably have also VMware in your environments today, so just know that we can in fact support that as well. If you are running a Commvault or a Veeam, that's already backing up your VMware environment as well, there's full support there for leveraging Azure storage with their respective providers as a backup targeted. So that's kind of backup as a whole, and let me just poll. I'm just going to check the audience really quick to see if there's any questions. I do not. Thank you, Simon, for putting your contact info in. So the next topic we really have is leveraging disaster recovery with Azure. Microsoft built their platform on top of, which is called, Azure Site Recovery. I'll refer to it as ASR the rest of this session. And ASR is meant not only as a disaster recovery tool, but as I'll get into later in the session, can also be used as a migration tool. In fact, it's a free migration tool of getting your on-premises workloads to Azure. I'll cover off on that in just a minute. So in a lot of cases today, most institutions are faced with the challenges of DR. Number one is always going to be the cost. And that cost is key because when you look at your top 3 budget items, it is typically going to be compute, storage, and networking. Those are going to be the things that when you talk about building out a co-location facility, it's going to be the colo cost, or it's going to be your facility plus power and cooling and having hot spares of hardware up and ready and running, as well as the licensing to do all of that. That's typically one of the biggest issues with most organizations is the cost of entry of disaster recovery is extremely high. So people avoid it and they take on backups as their primary. I'm here to tell you that we can really operationalize that cost with Azure Site Recovery. Microsoft has an extremely aggressive pricing model for this as well. I'm not going to get into costing, but there's a per instance cost that Microsoft has recently slashed in half for the enterprise market. Again, being institutions, you guys will get that even lower, much lower than most of the commercial enterprise customers as well. And just to give you an example of the commercial pricing, I won't speak EDU pricing, but if there's a per instance cost that you pay every month, which is about $25 a VM. So to put that in orders of magnitude, if I wanted to protect 10 VMs into Azure, I would only pay $250 per month. And then there's just a storage charge, which is extremely cheap, as I mentioned, to store 10 terabytes of data for only $224. That effectively means that for 10 terabytes of data across 10 VMs, my disaster recovery is going to be extremely cheap. I can't do math in my head this second, but 250 plus 224 is about $500. Again, very, very cost effective. When you look at that cost compared against the capital you're actually going to have to go out and purchase to go buy the colo and the power and the cooling, the storage and networking compute and the backup of all that data. In addition to cost being the biggest barrier of entry, it's also typically going to be complexity. In most cases, it's very difficult to protect complex environments. So even if you have backups today, if you ever have to go through the process of recovering a multi-tier application, if I don't have an application consistent snapshot of my database, my web tier, and my application tier, it means you're going to have disparate data sitting out there, and it actually may impact how the application can start. May affect your RTOs and your RPOs. The other thing about most of these scenarios today is that they're very complex to test. So what happens when I need to do a quarterly failover? Let's say over the summer when my student load is maybe a little bit less than my peak seasons, I want to be able to actually do a test failover and make sure this actually works. I will tell you that almost 60% of the institutions and organizations I walk into fail to do DR tests because they're afraid of the complexity and afraid of the impact of things like data loss and the time to fail back. And that last part is one of the most impactful. People are extremely afraid of that failback process and potential data loss, especially if you're running a campus that has students all season or has resources delivering to faculty. That can be a very significant impact to your user community. The other challenge is also protecting just a few workloads. In a lot of cases, folks really focus on their tier 0 and their tier 1, but what next? If we talk about that tier 3 and tier 4 that today you may be okay with rebuilding, that time can take weeks or months if your priorities are ensuring that things are running on a successful failover. So I want to kind of talk to you guys about today, how this process becomes extremely seamless as we move to something like an Azure Site Recovery. Now, Azure Site Recovery supports a handful of different scenarios. As I mentioned, Microsoft has opened their kimono from a non-Microsoft platform perspective. I can now do disaster recovery from VMware to Azure. I can do disaster recovery from physical servers to Azure, even though we hope that footprint's going down. This also allows me to do disaster recovery from a site that I own to another site. So if anyone on the call is a Hyper-V shop today and they use something like Hyper-V Replica, Hyper-V Replica in box is great. The problem is when I need to fail over more than, say, 10 VMs, I either need to, A, right-click every VM and hit move, and it's not going to be grouped or consistent, or I have to actually go and execute a PowerShell script to do that. And it's not as seamless. So in scenarios even where you do have a colo and maybe you've got a contract for another year or 2 years or 3 years or another campus data center, in a lot of these cases, this can still provide value in providing that automation or that workflow type of failover. And that's something I want to speak to as well is if you don't have, if you're a regional-based campus, one of the downsides of DR for you likely today is you're not using a colo provider outside of the state or more than 100 miles away is having that reach of getting that data somewhere else. When a natural disaster occurs, when something happens in one of your regions, the downside there is, well, if it impacts my DR data center as well, now I'm completely out. Microsoft today has 34 different Azure regions throughout the world. Very unlikely you'll be replicating your data to China. If you so choose, you have that option. But Microsoft, even in the US, has, I believe, about 10 different options or 9 different options for you to replicate to today, whether it be North Central, which has a data center just outside Chicago, South Central down in Texas, East US 2, West US, or Canadian data centers. There are various options that you have within Microsoft that they've already done the lifting and the hard work from a colo perspective. Again, treat them just like another colocation provider. The great thing about Azure and Azure Site Recovery is I talked about that cost. Well, if I'm not running that VM actively in that DR site, like you may be doing in some scenarios, I don't actually pay in Azure to consume that resource. So again, there's a per instance protection, and I don't pay compute, which is the highest cost in Azure of any cloud provider. I only pay for that when I need to fail over. So if 364 days out of the year I don't have to fail over because there's no events or disasters happening in my region or anything like that, I actually have the ability to say, okay, well, if I only want to fail over for 8 hours, do my testing and fail back, well, I only pay to run those 8 VMs or those 80 VMs for 8 hours or 10 hours. I recently went through a study with a customer, and we estimated that for a server environment of about 65 servers, which vary in size from 16 core and 128 gigs of memory down to 2 cores, 4 gigs of memory, their average runtime of those Azure resources was approximately $8.67 per hour. So again, take that into context for a weekend failover test. To run that environment, whatever, let's just round up to 10 times 24 will cost me under $250. And again, that customer is also enterprise. They're not paying the pricing that you guys have within education. Another very unique option that Microsoft also has is you can replicate this from any other data center provider. If you're an AWS customer, which does not provide any type of in-box disaster recovery today, you can also replicate data from another provider. And AWS is brought up here. However, it also works for Google Cloud or anything hosted in Rackspace, or maybe you outsource to a local provider. You can do all of this with any one of those types of providers as well. And as I want to wrap here, the last thing is, not only Windows, but any OS. This is also supported for any of your Linux-based workloads that are supported in Azure as well. So what does ASR bring to the table? One, it brings multiple scenarios across one singular solution. It allows for automatic VM-level replication of data, and this can be set up to do as low as 30-second replication intervals, or 5 minutes or 15 minutes, depending on what your RTOs and RPOs are. Those RPOs can go as little as seconds. Your RTOs can be as little as minutes. The other great thing about this is there can be a scenario called a test failover, which means I don't impact your production site. By replicating this data to Azure, it means I can actually bring it up in a private environment that doesn't route back to my production infrastructure, and allows me to bring that up in a bubble that I can then go test my student processes, my faculty logins, I can test my ETL jobs, how my data works, I can test my web applications, and all of that can be done without ever touching production. A lot of my customers have adopted this and doing these test failovers in a quarterly based model, and they may choose to do that planned failover type of model once a year. Reduces the impact to you, reduces your impact to your students vastly. The other options it offers as well are what are called unplanned and planned failovers. A planned failover means that I know an impending event is happening. Maybe I'm doing my VR test. Maybe I know there's a tornado coming, and I'm afraid that my data center may be impacted, or I know that Cogent has an outage to my internet connection. All scenarios in which you may choose to fail that data over. In a planned scenario, we cleanly shut down all resources. We replicate all consistent data, so there's zero data loss in that scenario. And then we bring them back online from that last consistent snapshot. The other option is an unplanned failover. So maybe an event happens, an outage occurs, and you did not plan for it. In this case, I can bring that data back up from, say, those last 30-second, 5-minute, 15-minute intervals. And I can bring those up in groups of applications. So that way my applications are consistent in how they're snapped and recovered as a part of that process. A lot of really great advantages to doing this, because really it allows for you to control the scenario and how you provide disaster recovery. Microsoft also has what are called recovery plans, and these allow me to dictate how I recover resources. Do I want to do my AD tier first? Do I want to then do SQL? Do I want to then do things such as my tier 0 through tier 4? The great thing about Microsoft having this kind of grouping is you also have the scale of Microsoft behind you. Today, if any of you may have like 250 VMs, when you try to fail over all 250 VMs at the same time to your 5 VMware hosts in the other data center, you're almost always going to be compute and memory limited, not necessarily storage, and sometimes you will be storage limited because latency is going to be extremely poor during that failover. But Microsoft, at their scale, the data centers they provide today, means you can scale out to those 250 threads across the various services. So your recovery times, where you may have boot storms in today on-prem in those recovery types of actions, can actually be extremely minimized because I'm deploying that across different compute nodes, across different storage nodes, that I'm really allowing you to fail that over in a consistent and quick manner. Microsoft also has failback support for everything as well. So if I do a full planned failover or an unplanned failover, we have the option of doing automatic reverse replication, where I can say, hey, when I do failover, make sure I connect that back to my on-prem VMware or Hyper-V and replicate any changes that are happening up there during that window. So when I fail back, I don't have to take everything down and then bring it back up. This allows for that seamless integration of recovery. This also allows for migration to Azure from anywhere. So as I mentioned, physical, virtual, being VMware or Hyper-V are all supported. And it also allows you to create on-demand test copies. So let's just say that you are looking to move a resource to Azure, or you're looking to do some type of dev and test type of scenario on an enterprise app. This also means you can use ASR to replicate that workload up into Azure and do all of your testing without having to do it on-prem. Think of this just like you would do a clone in VMware or say Hyper-V to test these various workloads. Now, ASR, as I mentioned, works in a couple different manners. Data is replicated directly from your primary site to Azure. In this model, there's a separate orchestration layer that doesn't do the replication, and that is what Azure Site Recovery is specifically doing. This represents a typical, three-tier application with Active Directory as the foundation. In this model, I can, protect all these items, as I'll show you in just a few minutes, and recover them all consistently. Now, you may find scenarios where you may need more active than 30-second based replication intervals. Great example of this would be something like SQL Always On, where I can replicate data synchronously now with SQL 2016 or asynchronously. This would be considered maybe my tier 0, where I do want to run that VM in Azure all the time. AD is also another great example of that. I don't want to have to wait for AD to fail over. I may want to just extend AD to Azure and have that infrastructure as a service VM running up there so that when I do fail over my other resources, they're up, AD is up and ready and consistent. And I absolutely recommend that from a recovery perspective. There are various ways of connecting those data channels to each other. So when you're talking about connecting to Azure today, you can connect via two primary mechanisms with Azure Site Recovery. One is over a traditional site-to-site tunnel VPN. And this is no different than something with your Fortinets or ASAs you have between different sites or from your home or maybe from two different campuses that are connected via distance. In this scenario, there are going to be some limits on that connectivity, meaning site-to-site connectivity is limited today to 100 Mbps or 200 Mbps. There's also another option that you as education customers have access to, which is leveraging your I2 networks. So in this case, I can actually extend an MPLS node up to Azure, and now I can have up to a 10 gigabit connection to Azure. So we start looking at the amount of data, especially with this DR, that you're replicating every 30 seconds. You may find with extremely large workloads that you're saturating that 100 or 200 Mbps connection. Also be aware that with site-to-site tunnels, they're not private, obviously. They're going to be more latent than, say, an express route connection with an MPLS. In this case, a standard site-to-site tunnel in my office is between 20 and 30 milliseconds. With express route, I'm going to be able to get a lower latent, higher bandwidth connection, and something you absolutely want to consider if you're looking at a longer-term solution of Azure Site Recovery for DR. Do not let that stop you from testing something like this, though. You don't necessarily, and I do want to point out, you don't have to have a site-to-site tunnel, by the way, for this. But if you want to do the communication layer, such as AD or SQL, obviously you need to have some type of connectivity between those active nodes. If you don't want to do that in Azure today, you actually don't need that site-to-site tunnel, and we actually route that over public endpoints that are secured with SSL. We've actually covered off on a majority of these, but again, some of the pillars for why Azure Site Recovery. Simple and cost-effective. As I said, you really shift a lot of that CapEx expenditure for your data center refresh, your DR refresh, or your new DR build-out to a more operational cost. It's heterogeneous, so supporting multiple workloads, Windows, Linux, Red Hat CentOS through COEL, etc. It's going to be application-aware. And I also want to point out, too, Microsoft also has a global load balancing service in Azure called Global Traffic Manager, or just Traffic Manager. What this allows me to do is actively check for valid connections back to your primary data center for maybe a student-facing application. And if I fail a transaction, we can immediately fail that over to the resource in Azure. I bring this up because DR is not just about replicating the data, but it's also getting your users and your sessions out to that Azure resource as well. We're changing IP addresses. We're changing locations. So if you don't have like an F5 or a Barracuda or any other provider that does global service load balancing today, NetScalers, Microsoft offers, what I'll call global service load balancing as a service. So you can ensure that when these applications fail over, your students, your faculty, your folks are going to be rerouted to that location automatically. Walk through what Azure Site Recovery looks like. So you guys saw a little bit of this in the portal earlier. So in the same backup vault here, I also have some items at the bottom here that are called Azure Site Recovery, or it is called Azure Site Recovery. Now at the base level, I can choose how I want to protect my VMs on premises or in VMware, etc. So I'm going to go down here to go to replicated items, and let's just say that I built a new server for a new web app, and I need to make sure that's protected in the cloud. Now I've already gone ahead and defined the policies for protection here. I'll come back to that in just a second. But for me to add a new VM is extremely easy. So I can go up here to hit the Add Replicate option. And we're already hooked in with VMware, or in this case, mine's Hyper-V, but you can hook in with VMware as well, obviously. Now I say I want that source to be my Hyper-V environment going to Azure. So here's just a demo cloud I have built on-prem. We choose the target, which in this case is going to be Azure. So we'll keep this as is. And then I'm going to get a list that's pre-populated of all of my VMs on premises, which is synced up to the Azure Site Recovery Service pretty regularly. So if I want, we can say, okay, well, I've got this new NDES server I want to protect, so we'll hit OK. We'll configure the properties of replication here. So in this case, Microsoft will prompt you for the type of operating system you have. So in this case, I know it's a Windows VM, so I'm going to select Windows. And we're going to go ahead and it's going to automatically select the type of disk and the relative size. Now, if you need a bigger disk or you want a smaller disk as you're failing over to Azure, there's an option for you to select. Maybe I have a VM that has 4 cores and 10 gigs of RAM, but I know when I fail it over to the cloud, I don't want to pay that much, and I don't care about having the exact same performance. You can, in fact, choose from the size of Azure VMs what you want that to be. So I'm going to go ahead and hit OK, and then we're going to review the replication settings. And this is a policy I've already pre-configured, but you can create a new one if you want. My policy is to copy every 15 minutes, which can be down as low as 30 seconds. It's doing an app consistent snapshot every hour and 2 hours of recovery retention, so essentially 2 point-in-time snapshots. Now, I do have my initial replication start time is immediate. You may choose not to do this because if you're enabling this during, business hours, school hours, well, certainly you could potentially saturate your line. So there are ways to implement this so I can schedule this after hours, maybe 1 in the morning, 2 in the morning. That way I don't impact any of my existing workloads. And then also I did mention earlier we can choose to encrypt that data when it does get stored on Azure as well. I'm not actually going to protect that VM, but once I do hit that OK button and hit Enable Replication, because of my policy, I will immediately go out to that server and start replicating the 15 gig disk out to Azure. And then within a matter of 10 to 20 minutes, depending on how my bandwidth is saturated today, that VM will then be in fact protected in Azure. In addition to individually protecting items, I alluded to the fact that there are also the option of creating what's called a recovery plan. Recovery plans allow me to create that orchestrated failover process of my on-prem to Azure failover process. So I have and actually, I'm sorry, I'm going to step back 1 second. If I did want to, I did want to point out here that if I wanted to, outside of that recovery plan, I can in fact fail over a VM individually as well. So maybe I'm doing some other testing and I want to just fail that VM over. Here I just chose one of my VMs, and up top, here are my different options. I can do what's called that planned failover, which means I shut down in my source, I replicate the final data for 0 data loss, and I bring it back up. We also have the unplanned failover option. So in this case, I may want to recover that data from a different point in time. So here we'll have that option, and we can't choose the shutdown option if it's still up as well. The last one is the really important one, though, that I wanted to point out, and how easy it is just to test failover a virtual machine. In this model, again, I bring that VM up in a private VLAN. So here I can go down here and choose my VLAN that doesn't route back to my on-prem infrastructure, and that way, again, I don't impact, again, having 2 VMs with the same name in Active Directory is not a good thing. So in this case, I actually would test failover all those resources to Azure. So that's individually how I could fail over a singular VM. So sorry, now once we got that covered, I'm going to go over to our recovery plan. So here's where I actually create the orchestrated action of failover. So I've got a recovery plan here that I was working on earlier today, actually. And this recovery plan has just 1 VM in it, but I could have obviously multiple. We'll go ahead and look at that recovery plan really quickly here. And you're going to see this recovery plan, well, it has just 1 VM. It's fairly straightforward. In this recovery plan, let me just expand all these actions really quickly here. We'll see that I first shut down everything in the source. I then fail over my VM. So here's my ASR demo VM. We then start that virtual machine, and then we have a script that runs after the fact. Now, the great thing about this being, primarily Microsoft, and the fact that I can integrate with PowerShell, including on Linux, is the fact that I can run post-recovery actions. So if I need to restart a service, or I need to recycle an application pool, register an object, if I need to make a registry change, if I need to write something to log, I can all add that automated action as a part of this. Another example is I may need to open up port 80 for that web service, which is not done automatically. All that would be a part of that recovery plan. And again, if I wanted to, I could go add additional VMs in here as well. And if I want to add additional VMs as a part of this process, I can go over here actually and add additional VMs I want to recover over. So here I may build out my tier 1, 2, and 3. And also I can do things such as add that post action. And that post action would be a script that I've already developed that will either open up a port in Azure or restart a service. Choose your own adventure. If you guys have any runbooks built today for recovery planning and processes, you can pretty much do whatever you'd like. And this is all leveraging a solution called Azure Automation, which you have access to by leveraging Azure as well. And I should also point out, I showed a post action, but there's also pre-actions as well. So if I need to quiesce an Oracle database or a Sybase database and shut it down cleanly before I do a failover, that's a prime example of how I can not only execute automated actions in the cloud, but also execute those automated actions on premises as well. Just like I showed you in the individual VM failover, I also have the same options here where I can do things like the test failover, the planned failover, the unplanned failover. So if I wanted to failover my entire environment, we've actually done this, and we've handed secretaries a one-page sheet on how to failover an environment. Obviously, you want to be mindful of that. The hope is that you have one resource that may be off-site that can do this in the event of some type of disaster. But if I wanted to do that, I just log into the Azure portal. You'd have this object pinned. I would go over to planned failover, and we would get our option. It is extremely easy. We're going to get a source and a destination, and we're going to hit OK. That in itself can execute that failover action. So here's the failover direction. I can choose how I want to synchronize data after it fails over, and I'm not going to do this, but when I hit OK, it will actually execute that action. Now with Hyper-V VMs, generally that recovery action takes between 3 and 5 minutes to fail over that resource in an unplanned scenario. In VMware and Gen 2 Hyper-V, it will take a little bit longer, but again, I can execute all those actions in parallel. So, when we're even talking days to recover, or sometimes weeks with some environments, I can do this in a matter of, of minutes or hours. So, reduces that level of scale quite a bit. And just like on the backup side, I do get email alert notifications as well. If there's failures due to replication, maybe I've got a inconsistent site-to-site tunnel, or a replication fails because for some reason the server went offline on-prem that's tracking those changes. Different scenarios there are all tracked via alerting and events as well. So the last scenario here, and I'm actually not going to show any demo on this, but ASR, as I mentioned, can also be a tool for migration. Microsoft provides their customers ASR for free for up to 30 days of migration activities. And you do have to migrate. It's not meant for protection. This allows me to take any VMware or physical or Hyper-V or AWS or Google Cloud-based workload and migrate them across cloud providers. And if anyone's ever worked in AWS, you know that one of the downsides is they're a lock-in platform, meaning I can't take that data out even back on-prem easily without agent-based tools. In this model, I can migrate solutions across cloud providers. And everything I just showed you from a protection perspective is absolutely accurate from a migration perspective. The only difference is at the very end, I do a planned failover, or after a planned failover, I do a committed action, which actually removes the source, and then it gets brought up in its final destination. In this case, would be Azure. So as you guys start adopting and understanding and using Azure more, certainly don't lose sight of the fact that Azure Site Recovery can also be a fantastic migration tool as well. So let me see if there's any questions, and I will close. I'll actually open up the floor as well in here in just a second. So I don't see any questions in the window. Before I take the last few minutes here for any questions, I'll unmute everyone if you want to talk. We do have some upcoming further sessions throughout the rest of the year for this Azure123 series for education. Next week, we'll be delivering a session on developing new capabilities with faster cloud app development. We'll be then delivering a session on hybrid tooling and moving to the cloud. We'll then be talking about deploying workloads in the cloud and increasing your security posture versus what you have on-prem today. And we'll be wrapping the year with a session on security and identity and access for students and faculty. So if you don't have these invites, again, you can go find the the links for registering for those as well at Azure123.rocks.com. You can also obviously ping Simon or myself or marketing at netrixllc.com for any further information. Or if you'd like to continue this discussion and do a bit of a deeper dive on things like Azure Site Recovery and Azure in general, that's really why we're here and why we partner with Microsoft. So, that is the end of today's presentation. I see a couple of questions.
Yeah, I think we have a few questions for you, Rich.
Yep. So, first question from Art, is Azure Domain Services required for Azure Site Recovery? No, it is not. Either is ADFS. So, ADDS is primarily, so for everyone else, ADDS is a solution that just got launched 2 weeks ago, which is essentially a Active Directory as a platform as a service. What I actually recommend, there are some limitations to ADDS today. I do recommend having a full domain controller up there and running if it's possible to do so that when you fail over authentication, it's going to work properly. But you can also don't have to do that, and you can also, it is supported to replicate domain controllers or AD controllers to Azure with ASR. ADFS is just an authentication mechanism. So in this case, that is absolutely not required for this. Your Azure tenant does not have to be integrated with ADFS in order for any of this to work. There's actually zero impact from an ADFS perspective in how this works. And I don't think there's a question from Joe. I just saw the session title in there. So I'm going to do one last thing here. I'm going to go ahead and unmute the audience, and I'll open up the floor for about the last 8 minutes or so. So Art, you asked, does ASR replace or does it augment Zerto? I have not worked with Zerto much. I believe, and if you want to come off mute too, maybe you can explain to me how you're using Zerto today, and I can answer a little bit more clear. Otherwise, we can take it offline if you're not able to unmute. I just unmute the audience as well. So I believe Zerto is an off-site backup solution. Again, Azure Site Recovery, or the DR side of it, would be a separate process from Zerto. But I don't have a lot of experience with Zerto. So Art, if you're not able to unmute yourself, feel free to shoot me a follow-up. I'll shoot my email in the chat window here. Feel free, and I'd be happy to follow up with you on that one. Does anyone else have any other questions on Azure Site Recovery or backup and DR with Azure? Simon, any closing thoughts?
I think certainly from my point, the point of these sessions are to make this a little less confusing and see actually, how easy it can be, especially for the K through 12. So no, thank you for another very informative session.
Of course, and I just saw one last question pop in from Art as well. So Azure Traffic Manager, I'm going to put a link in the IM window here. There's a pricing model for Azure Traffic Manager for geographic load balancing, and there's public pricing on that page and how it's costed. Again, your pricing from an EDU perspective will be cheaper. So if you have any specific follow-up questions on that too, feel free to shoot me and Simon or anyone else a note on that as well. All right, with that, Simon, you can go ahead and stop the recording.